Welcome. So, excuse my voice. This is recording this when I'm getting over a little bit of a chest thing. So I apologize for all the coughing here. So in this video, in this lab, what we're going to be talking about is doing some exploration. Okay. Now, realize you're not going to understand all this stuff yet. So far in this class, really all we've talked about is Ethernet. And we've mentioned IP version 4, but we really haven't delved into it much, but we will be doing that shortly. What we really want to do here is do some exploration and some comparisons. So yeah, let's go ahead and get started. So this video will be showing you exactly what you need to do using Packet Tracer. And please do it on your own. Download this Packet Tracer topology. Do some explorations, even look at things maybe that I'm not talking about here. Just look at some different things. Okay, let's get started. So the first thing I'm going to do is I'm going to click here on PC3. I'm going to put that over here. All right, and I'm going to click on desktop, command prompt, and I'm going to expand this just a little bit. And I'm going to type the command IP. This is a Windows command, ipconfig /all. And let me scroll up here. Really what I'm looking at here is the stuff for the fast Ethernet connection. And some of the things I can see is, and this is things that you want to pay attention to and that you'll be putting down for your answers on the Canvas quiz. What is the Ethernet MAC address of PC3? And we can see that right here. It's known as a physical address or sometimes as a burned in address because it's actually on the network interface card. Let's take a look at some other information as well. What is the IPv4 address of PC3? Well, we can see that right here. There's the IPv4 address, and it'll ask, what is the subnet mask? Okay. Okay, if you hear a little pause there, it's only because I'm muting and coughing while I do this. We haven't really talked about the subnet mask, but we will when we get into IPv4. Okay. The next thing that we want to do is also look at something called the default gateway address. This is the IP address of the local router where PC3 is going to send any packets to that is not in its IP network. And we'll be talking more about that as well later. Okay, so the next thing we want to do, and this is just, we'll talk more about all this addressing stuff in just, in just a week or two. Now let's do this. In PC3, what I want to do is do some exploration of the Ethernet network interface card and also examine some more of the IPv4 addressing information in a slightly different way. So what we're going to do is click here on the config tab, right? And then make sure interface. And then if you click on interface, by the way, notice that the interfaces go away. If you don't see them, click on it again. And the interface we want to make sure we're selected on is Fast Ethernet 0. All right, so let's take a look at some stuff here. Excuse me. So port status. The port status is on. That means it's enabled. So on your network interface card on your devices, you can actually enable and disable your Ethernet NIC card. You can also do the same thing for your wireless NIC card. The next thing we want to take a look at is bandwidth. And what is the bandwidth set to? What is the check mark? And notice that it is auto. Okay, so it is actually auto negotiating. Let me see if I can just move this slightly without creating a big problem. Let me go here. So yeah, let me move this a little closer. There you go. What's happening here is the NIC card on PC3 is auto negotiating with the the port on the switch that it's connected to. And what is the current bandwidth? What has it auto negotiated to? Well, we can see here that it's 100 megabits. Okay, so that means that this is the highest bandwidth that this NIC card can do. And yes, the switch port that we're connected to supports 100 megabits. Next thing we want to look at is what is the duplex set to? So if I come over here and I look at duplex, it is also auto negotiating. So remember that the PC NIC card, Ethernet NIC card, and the port on the switch auto negotiate both bandwidth and duplex. What is the best we can both do? Now, if you take a look, what is the current duplex? And these are called radio buttons, by the way, that you can see the little button there, a little circle with the dot means it's so that's what's current. But it has auto-negotiated full duplex. So both the NIC card on this PC3 and the switch port can both do full duplex, which is very good. We don't want to do half duplex unless we're connected to a switch. I'm sorry, unless we're connected to a hub. Why do I say switch? No, switches do full duplex. Okay, now notice, let me kind of get rid of that here, clear this. Notice that, yes, can you modify the Ethernet MAC address? Yes, you can. You can even do that on your NIC card typically, but don't do this, okay? All right, there's no reason to do this, all right? But yes, you can modify the Ethernet NIC, Ethernet MAC address on the NIC. The other question I want to ask you is, can you modify the IPv4 address and subnet mask? And yes, you can. Again, don't do this. Now, we have statically configured this, or I've done it for you, statically configured this address. Typically, you only statically configure IP addressing information on things like routers and servers. On client computers like this here, typically what we would use is DHCP. We'll talk about that later, and we'll be using it later. We will even later configure one of the servers as a DHCP server. How cool is that? All right, but we'll get there. When? Of course, later. All right, the next thing we want to do is, this is kind of the IPv4 addressing information, but not all of it. Let's take a look at this. Next, what we're going to do is we're stay on the config tab, and we're going to go to global and then click on settings. And again, if you don't see settings, just click on global and click on settings and you'll see it. Okay, so question here is, what is the IPv4 address of the default gateway? And it's right here. Okay, and can you change it? Yes, but don't. Okay, so make sure you know how to get this information both with ipconfig /all, but also here on Packet Tracer, we can statically, again, we're statically configuring this information. Okay, and once again, that's not normally how we would do it on our client computers. We use DHCP, which we'll do that later. And that will all make more sense later. Okay, again, we're just doing a little exploration. All right, the next thing we'd like to do is, let me close this. And what I'm going to do is come over here and bring up the router 0. Okay, how cool is this? You can even see physically the router. If you zoom in, there's its gigabit Ethernet 000 port and its 001 ports right up there. All right, but what we are going to do is we are going to go to config, interface, and we're going to look at two interfaces. So notice the router has multiple interfaces. That's what a router does, it has different interfaces. In this case, different Ethernet interfaces. So it has different Ethernet NIC cards. And we're going to do some exploration on this as well. So the first thing is, let's click on gigabit 000. Again, you don't see these. Click on interface, click on gigabit Ethernet 000. That means it's gigabit. Gigabit is 1 billion bits per second. All right, same types of questions. Okay. First of all, what is the MAC address? And it's right here. Okay, there's our MAC address for that Ethernet NIC card on gigabit 000. Also, what is the IPv4 address and subnet mask of that interface? We see the IPv4 address and we see the subnet mask. Now you'll also notice that similar to an Ethernet NIC card on your client, you can enable or disable the NIC card on or off. The bandwidth here is also set to auto negotiate. So it's actually auto negotiating with this switch right here in that port. Okay, notice that it is auto negotiating and 1000 megabits. That's gigabit. That means that this switch port can and this interface can both do 1000 megabits, 1 gigabit. And they're both auto negotiating the duplex to full duplex. Okay. Now let's take a look at gigabit 001. So that's the other interface over here. So let's click on that. Okay. So notice that it has a different Ethernet NIC card with a different Ethernet MAC address. Okay. Now notice, let me click back and forth here. Notice, look at this Ethernet MAC address. Now look at the one on 000. They look similar. I'm going to click back and forth. Can you see? Ah, yeah, they are different, but they are unique. One has a 1 that ends in a 1, the other one ends in a 2. Okay. All right. We'll talk more about that in just a moment. All right. So notice that gigabit 001 has a different, not just a different MAC address, but a different IP address, and in this case, also a different subnet mask, because this is a different network. And we'll be talking about that more later. Okay. And you'll notice it too. The port status is on. It auto negotiates bandwidth and duplex, and it also has auto negotiated 1000 megabits full duplex. In this case, this port here has auto negotiated it with this switch port here. All right. Let's take a look at these two interfaces here. Once again, the MAC addresses. Remember that an Ethernet MAC address, the first 24 bits or 6 hexadecimal digits represents the organizationally unique identifier, OUI. That's the vendor. That's who created this Ethernet NIC card, who manufactured. No, so this OUI is one of Cisco's. Okay, so notice it's 00500F. If you look at this one here on gigabit 001, you'll notice, oh, same OUI. It doesn't have to be, but it happens to be the same vendor. But what's different is we look at this part here. That's what has to be unique with this specific OUI. So that last 6 hexadecimal digits, 24 bits, has to be unique, and it is. One ends in a 2, the other one ends in a 1. Okay. So remember, the OUI is 6 hexadecimal digits, and the unique part is 6 hexadecimal digits. Each of the hexadecimal digits is 4 bits. All right, let's do a little comparison here. Okay, just kind of a little exploration and looking at things. So what I have done is I have shown you on here some of the MAC addresses and that sort of thing. So here's the MAC address for the different devices. So if we look at these MAC addresses, all of these MAC addresses here. All right. You'll notice that there really isn't anything, even on, we have 2 networks here, the router's dividing the 2 networks. There's nothing on this network that makes them all kind of anything that makes them all have kind of a similar part of their address. They're all unique MAC addresses. There's nothing that indicates what network they belong to. They just have to be unique. All right. Now, let's take a look at the difference between that and IPv4 addresses. So let's take a look at the IPv4 addresses here, first of all. So here's an IPv4 address. Here's an IPv4 address. Here's an IPv4 address. Here's an IPv4 address. IPv4 address, IPv4 address. Okay. Now, first of all, that /24 you see there, the /24 is actually the subnet mask. Okay, we'll talk more about that later. We're showing it in a different notation, but this is the subnet mask. And actually, this is the same as 255.255.255.0. But don't worry about that right now. But just do notice, however, that they all do have the same subnet mask. Did you notice that? Yeah. Even the router has an IP address, same subnet mask. Okay, that's important. All the devices on the same IP network need to have the same subnet mask. Okay, let's go back to the IP addresses themselves. Notice that each of the addresses, if we look at these addresses, do they have a part that's in common? And they do. In this case, not always, in this case, notice that the first three numbers for all of them begin in 192.168.1, 192.168.1, 192.168.1. We'll be talking more about that later, but that's what we call the network portion of the address. They all belong to the same network, but they all have a different host portion on that network. So notice they have one part of the address that uniquely identifies them on that network, like 100 or 101, 102, 103, 50, even the router, a 1. Okay. Notice over here, by the way, let's separate this. What about over here? Same thing. We have, the router has an IP address, and we just have one device on this network, the server. But notice that, first of all, let's look at the subnet mask. I'll just put an underline there. They both have /16s. Okay, same subnet mask. /16, by the way, is 255.255.0.0. We'll get there later. Same subnet mask. But also notice that they have similarities in their IP addresses. Okay. Now, in this case, we'll talk about it later. The network portion is actually the 10.0, just the 10.0. That's it. The host portion that uniquely identifies them in this case, and you'll learn why it's the last 2 digits here later. Don't worry about that now. But the host portion is 001 and 099. So we have, let me kind of show you, network, host. The network, host portion, okay? Over here, the network portion was the first 3 digits. The host was the last digit that uniquely identified it on this network. Over here, the first 2 digits is the network address, and the last 2 digits was the host address that uniquely identified it on this network. So we haven't gotten into IP, right? But I want you to start saying, MAC addresses didn't matter. Okay, they didn't have any structure to them. Network portion, host portion, but you'll notice that there's some similarities with IP addresses. And we're going to do a little more exploration on that in just a moment. And a little test, a little validation on it as well. Also, one last thing, the default gateway address. Notice that all these devices have a default gateway address. And what is that default gateway? If you look at all of them, their address, where is that? Whose IP address is that? Who does it belong to? Ah, yes, the local router. Same thing over here. This, or one server here, has a IP default gateway address, and who does that belong to? Its local router. Two separate networks. Okay. We'll learn more about this when? Of course, later. Okay, now this is cool. Let's take a look at doing a little testing on all this cool stuff here. So what I am going to do here is I'm going to go to PC3 again. So let me bring up PC3. Okay, now what I'm going to do is go to the desktop, command prompt once again. Okay, and I'm going to use a command that we're going to learn more about a little later. Okay, and what that command is ping. And what I'm going to do is I'm going to ping actually PC1 here, its IP address. Ping is a utility that can see if we have reachability. Test to see if can we communicate to each other. Okay, so I do a ping here. Now, if that first reply fails, times out, don't worry. That's not uncommon. We'll talk about that a little later, very soon, as a matter of fact. But it sends these 4 pings. It sends basically sending a message to this IP address, this device with this IP address, and says, hey, are you there? And in this case, PC1 with that IP address. Oh, no, it's not P. Who did I send it to? I'm sorry, PC0. All right, typed in the wrong address. Or no, I mentioned the wrong one. Okay, PC, here it is. Here it is. I was saying PC1 is PC0. PC1 sent 4 actually of these requests. And PC0 says, yep, that's my IP address, and sent back 4 replies. Okay, so that's how we can test. Hey, we can actually communicate. Can we communicate with the server? Well, let's take a look. I can actually ping that server. Okay, let's see here. That's okay. That first one timed out. We'll learn about why later, but I'll mention it. It had to do something called an ARP request and wait for an ARP reply. What is that? We'll get there. Actually, we'll be talking about that in the lecture. All right. So yes, we can communicate with both devices. Okay, let's do something now. What I'm going to do now is this. I am going to move PC3 to another network. So the first thing I'm going to do is go over here to this little delete key with the X, select it. Notice my cursor turns into an X, and I'm going to click this link right here. If you make a mistake, just go up here to Packet Tracer, do edit, undo. Okay. Well, we'll talk about that link light a little later in the lecture. This actually next week. All right. So, but let's get rid of that. So let me do an X again, get rid of this link. Then I'm going to go back up here. I'm going to choose the select key. See that right up there in the left there? Choose select. Okay. And what I'm going to do is I'm going to move this PC. And I'm going to move it over here. Okay. And what I am going to do is I'm going to connect this PC to this switch. Oops. Now, sometimes you wand over a switch like this, you get all this stuff. Don't worry about that. All right, so what I'm going to do is go over here to my connections. Remember, I have to use a copper straight through, okay, unlike devices here. Click on PC3, fast Ethernet, go over to my switch, click on the switch, and any of these ports is fine, doesn't matter. Okay, now notice that this light here is amber. We're going to talk about that in one of the lectures, but it's going through a spanning tree protocol. Make sure that this isn't causing a loop in our Ethernet LAN. That will turn green in about 50 seconds. Protocol developed by Radia Perlman. We'll talk about that a little later. All right, so what we want to do is some exploration here. Okay, so remember, here was our current, over here on the right, we can see what our IP addresses were that were statically configured and the MAC address. So up there, got a green link light. let's click on PC3 and let's do some exploration again. Okay, and let me move that up here so maybe we can see what it was previously. Okay, so what I'm going to do is different ways I can do this, but I'm just going to go to the desktop command prompt. And once again, I'm going to type ipconfig /all. Okay. Now, what I'm wondering is, did the MAC address change? So the MAC address shows as 00D0, all that BA76. That's what it was before, right over here. Did not change. So the MAC address did not change. Did we did the IPv4 address automatically change? Now remember, we're doing this statically, manually. So looks like it has the same, excuse me, same IPv4 address, 192.168.1.103. That was over here, but it's over in this network now. Now it has an IPv4 address that is different than the devices on this network. How about its default gateway address? Did it change? No, didn't change. Okay, so matter of fact, what I'm going to do is I'm going to move this right here so we can see, yep, none of that changed. I'll move this down a little bit. None of it changed. Okay, well, does that change how we can now communicate with other devices? Let's take a look. Remember before PC3 could communicate with PC0? Okay, can it do it now? Let's try it. Ping. By the way, I can use the up arrow. There we go. Ping 192.168.1.100. Let's see what happens. What do you think is going to happen? It's not unusual for the first one to time out. It is possible the second one could time out. But when we start seeing the third one time out and our last one time out, come on. No. None of them, no, they all failed. Okay. Well, if we can't ping a device in another network, can we ping, say, this server? We're on the same switch. Can we reach each other? We're on the same switch. Don't they see each other? Remember, devices live in a bubble. They don't see anything but themselves. But let's try the ping now from PC3 to server 0. Different IP addresses. This isn't looking good, is it? Okay. So remember, although Ethernet MAC addresses, they have nothing in common with other devices in the network, our IP addressing does have to match devices within our own network. So let's do this. Let's go ahead and change PC3. Okay, so what I'm going to do is actually, I'm going to go to config prompt or the config tab on PC3. I'm going to go interface, it's not selected. There we go. Fast Ethernet. And I'm going to change its IP address. I'm going to change it to an IP address that is on this same network as server 0 and the router's gigabit 001 interface. So I'm going to change this to 10.0.0.0. Again, I'm doing this statically. Now I've also got to change the mask to match. You got to be very careful about making any typos here. Okay, so that's the IPv4 address and subnet mask. We're not touching the MAC address. That doesn't matter. Okay, but there's something else I need to change. So this is fine. We now have an IP address and subnet mask that will allow it to reach devices in its own network. But how about reaching devices outside its own network? Remember, its local post office is now different. It's like when you move from Santa Cruz, where your local post office is no longer Santa Cruz, to, let's say, San Jose. Now you have a different local post office. So what we have to do is global settings, click on settings, and change the default gateway to be that of your local router. this case, our local router has the IP address 10.0.0.1. Put that one in there, that dot. All right. Now let's take a look. Now let's go back to the desktop. Command prompt. By the way, you can always close that and come back in. Okay, that's a little X right there. Okay, so now let's do some testing. Let me try first, can I even ping my device on my own network? That's usually where you start. Ah, yes, now we can talk. Now we can talk. Hey, yeah, we changed this, remember? So let me actually put this. We changed this to 10.0.0. What did I change that to? 50, right? Okay, 50. Okay, and that was actually a /16 subnet mask. I changed the default gateway, right? To 10.0.0.1, the local router. Okay, now we remember, so we made those changes. Now, okay, now we're looking more. This is why this is working. Well, now that I have the IP address of my local router, the default gateway, can I now communicate with devices on other networks? Well, let's give that a shot. Do we have a problem? No, only the first one timed out. All right. So those pings were successful. And so what I want you to get from all of this is that notice that what is similar, what isn't, what has to change, and what doesn't have to. Again, your Ethernet MAC addresses, they're unique. There's nothing on these Ethernet MAC addresses that indicate where the device is. But the IP addressing information is important. We have to have a consistency within our network. Remember, the router divides our two networks. Okay, so devices on this side are all going to have similar information, like the network portion of their address. They're going to have the same subnet masks. And these devices will all have the same default gateway, which will be the router. And that holds true for every network, including this one. These devices have different, well, a different IP network address, but they all have the same network portion of their address. They're on a different network than these devices, what I was trying to say. Different, and they all have unique host portions. Subnet mask is the same. And the default gateway is the router's IP address. One last thing I want to mention here is just to help you out with Packet Tracer a little bit. When you're on Packet Tracer, you can move these things around, okay? Make it easier to see. You also have some other options, preferences. So for example, some of the options that you have here, if you want to show port labels, okay, let me click on this one right here and I click on that. This shows you the ports like gigabit 000, gigabit 01 on the switch, fast Ethernet 01. Fast Ethernet is 100 megabit. The NIC cards on the PCs are all fast Ethernet 0. So you can see port numbers. You can also link lights. So you're seeing these green link lights and stuff. We'll talk more about that, but that's the link lights. You can also change things like the fonts. So the size of the font that you're working with. So I made it a little bigger so that we could see. All right. So we have not discussed IP addressing in detail, but we will be doing that and be understanding all of this shortly. So I hope you are beginning to see the difference of, well, Ethernet's role, but also IP. And when you have a device, when you take your phone, your laptop from school to home, it's going to have the same Ethernet MAC address. By the way, your wireless NIC card has a MAC address, 48 bits also. Those don't change. But you will get a new IPv4 address. You will get maybe a different subnet mask. Maybe it'll be the same, but we'll talk about that. It goes with the network. So there's to be that subnet mask of the network. but you also have a new default gateway, new local post office. All right. Don't forget, download this packet tracer, play with it, look at the different parts, answer the questions on Canvas. Yeah, we'll learn more about all this stuff later. Have a great rest of your day.